Today we have to discuss about nanochemistry. In fact, chemistry is a part of nanoscience and technology, and all other sciences are there in technology and engineering, medicine. Everything is there in nanoscience and technology. In fact, chemistry has lot many things to do in the world of nano, because as you know, the world of nano is a multidisciplinary subject where every other disciplines will also have their own contribution to the progress and development of this area of science. In fact, the word nano was very popular, and there were a survey which was conducted in US in some schools, I suppose. They just asked the students, where did you hear the word nanoscience and technology? So they had given several options, and a few people or several people were given the answer from the school itself. They had the word nano, and then newspaper, magazine, journals, several people were answered like that, television, movies, books, etc., and then from their friends, their own friends. So why people are hearing the word nanoscience and technology from various mediums and their own friends, television, movies, books, even in Spider-Man, the Peter, the hero, Spider-Man was mentioning that he is going to do research in nano. So this word was so popular, each and everything do in the society is connected to the nano. You might have heard about nano car. Nano car is not actually nano car, but it is smaller than other cars available in the market. So because they had given the word nano mainly because the word is so powerful. So in everywhere you can see, from newspaper, magazines, you can hear the word nano these days, because it's a very hot area of research and several things has to be done in nanoscience and technology. So chemistry can contribute, physics can contribute, zoology can contribute, botany can contribute, technology can contribute, engineering can contribute, medicine can contribute. Every scientist in different fields can contribute to the progress of nanoscience and technology. And now, what is nanotechnology? Nanotechnology or nanoscience is concerned with the use and control of structures that are 1 to 100 nanometer in size. So the nanomaterials are normally confined to a size of 1 to 100 nanometer. 1 nanometer is 0.1 Armstrong. So this is, we are playing with almost atomic levels. Literally we can see the atoms, or literally we can play with the atoms. So we have very powerful microscopes available, electron microscopes available to see the nanomaterials, and we define nanomaterials within a size range of 1 to 100 nanometer size. And this tiny matter is referred to as nanoparticles, and these particles are measured in nanometer size. A nanometer is 1 billionth of a meter. So 1 meter divided by 100 crores, then you will get 1 nanometer. So 1 billion means 100 crores. 1 by 100 crores you will get nanometer. And some of these nanoparticles occur naturally. For example, in volcanic ash, when volcano eruption is taking place, there are several dust particles and ash particles will be emitted to the atmosphere. And very tiny sized particles, we may not be able to see it, are observed in the nanoscale. And some occurs by accident, for example during the combustion of the fuels. And then many can be made by design. Design means you can synthesize the nanomaterials in different shapes. That is what is the design. And naturally occurring nanoparticles are there, and also you can make synthetic nanoparticles also. What are the properties of the nanoparticles? Nanoparticles of a material show different properties. compared to the larger particles of the same material. Why nano is very popular and very important? This is mainly because the first point says that when particle size reduced to the nanoscale, the properties are totally different than that material exists in its bulk form. Okay, and the forces of attraction between surfaces can appear to be weak on a larger scale, but on the nanoscale they are very strong. Because when the particle size reduced to nano, effectively what happens is the surface area of the material increases tremendously. The forces of attraction between surfaces can appear to be weak on a larger scale, but on a nanoscale they are very strong. And one reason for this is the surface area to volume ratio. In nanoparticles, this is very large. Surface area compared to the volume is very, very large in nanoparticles. So we will discuss it after a few slides. Atoms on the surface of a material are often more reactive than those in the center. So a large surface area means the material is more reactive because more surface atoms will be available, so it can easily react. So it is unlikely in bulk materials. That is why nanomaterials are showing different characteristics than its bulk material. So we are comparing different materials and their sizes. For example, like one raindrop, we have taken this on a chambala. Okay, its size is almost 1 millimeter. We have measured, and our hair diameter is 100 micrometer. When you are able to divide it like this, vertically like this, 4,000 times, then you will reach nano size. One hair we may not be able to think to divide by 2 pieces. Then the same hair has to be cut by 100 times vertically, 1,000 times vertically. Impossible. Red blood cells 5 micron in size, and in this scale flu virus 100 nanometer in size. Nanoparticles we can make gold nanoparticles 30 nanometer to 50 nanometer in size. DNA diameter is 2 nanometer. So here we are almost playing with the flu virus. The size of the nanoparticle is low than flu virus. So we can add a drug, bind a drug to the nanoparticles, and this nanoparticle will go to the flu virus and it can destroy it. That is what the idea is. And now, whether you have learned polymer, whether there is any comparison between macro and nano. In fact, there is no comparison. Macro has its own advantages, nano has its own advantages. We need both. So we have to keep a balance between nano and macro. So we cannot compare nano and macro, both we need. A short history of the nanomaterials. Early history, nanomaterials were produced by meteorite dust. When meteorites are hitting together, then tiny dust particles will form. This may be in nano size. Seashells and skeletons. The particles from seashells and skeletons may form in the nanoscale. Nanoscaled smoke particles generated from fire by the early humans. From the smoke generated from the fire, the smoke particles they obtained in nanoscale. The Maya century, one of the oldest civilizations. It has happened, the Maya civilization was there in 2000 BC to 250 AD. They used a kind of blue paint. It is the picture is shown here. This is the blue paint. Is a nanostructured hybrid material. The advantage of this blue paint is it will not fade. In 2000 BC itself, people were able to make nanoparticles. In fact, those people may not be able to know whether that particle is in nano or not. So later stages, the scientists, because of the non-fading characteristics of this particular pigment or paint, scientists were studied about this material. They found that this material is in the nano size. And Roman emperors Lycurgus cup. 4th century Roman emperors were using a particular cup for drinking the maybe the alcohol or maybe the beverages or wine or something. They are using very superior cups. It was made up of gold or silver or precious metals. They only the emperors can afford it. Nobody else. So it was made by very skillful people at that time, and so they made it so beautifully. And nowadays the scientists were studied about the Lycurgus cup, how did it made, and how did it make, and what is the material used, why it is so superior. So they came to know that this is made up of nano gold or nano silver. I'll show you it. The glass colored with nano gold and silver in the BC itself. That's what BC itself they were able to do. They were so skilled and so engineered. The ancient Roman nanotechnology. So this is the Lycurgus cup. Roman emperors were used this cup for drinking wine or beverages or something like that. So here, reflected light. When you light the cup from outside, like when you use a torch and apply the light, and when the light falls on the cup and it will reflect back, and reflected color is green. When you put a candle inside the cup, and then the light will be transmitted out from the cup, and that color is red. So this is the optical properties are totally different. The reflected color gets one color and transmitted light gets another color. When scientists investigated about this, they came to know that this is mainly because of the nano silver or gold particles present in the silver in the Lycurgus cup. So they were so skillful. And modern scientific history, colloidal gold was made by Faraday in 1857. In fact, Faraday was not knowing at that time whether he made nano gold or not. In fact, he thought he called that gold nano particles dissolved in water as the divided gold. In fact, he was able to dissolve gold in water. We were not able to think. We are using gold as the ornament. So Faraday was able to dissolve gold in water. Gold can dissolve in water only if it goes to the nanoscale. The nanostructured catalysts have also been investigated for over 70 years. So the catalytic activities also increases tremendously if we use the material in the nano. So as you might have studied about catalytic converters in vehicles. Catalytic fine particles of platinum. Platinum is a noble metal. It will not react with anything in the bulk form. But when platinum is in the nano form, it is acting as an excellent catalyst. It is used in the catalytic converters in vehicles. Precipitated fumed silica nanoparticles were being manufactured and sold in USA and Germany as substitutes for ultra-fine carbon black for rubber reinforcement in the early 1940s. 1940s itself, they use silica nanoparticles as a filler in rubber reinforcement. It will give more strength to the rubber. So it can be used for particular applications like tire, etc. 1960s and 1970s, metallic nanopowders for magnetic recording tapes were developed. Metallic nanopowders were developed. In fact, they were not knowing whether this is in the nanoscale or not, or they were not able to know what is the size of the particles or powders they made. 1964, scanning tunneling microscope was discovered. So this is the first microscope to identify the size of the material, whether it is in nano or not. Now we were able to see the particle up to the nanoscale. In 64, they were able to find the particle in the nanoscale. 1976, nanocrystals were produced. He is the scientist. He made a kind of prophecy in 1959. He is a physicist. His name is Richard Feynman. in American Physical Conference, he made a presentation. The presentation title entitled "There is plenty of room at the bottom." There is plenty of room at the bottom. Richard Feynman, wonderful man. He was thinking differently. He was talking about some materials in the nanoscale, some materials in the very tiny particles. So there are plenty of things to be discovered. Still, plenty of things to be discovered. Lot of advancement has to become when you reduce the size of the material. That's what the plenty of room is available when you go to the atomic scale. Plenty of things you can do when you go to the atomic scale. So that's what his kind of a prophetic type of talk he had given in the American Physical Conference in 1959. There is plenty of room at the bottom. So here you can see the atoms. So this image was made from is a atomic force microscope image, and here you can see the atoms. The blue colored is atoms. So literally you can see atoms. Literally you can play with atoms. There is plenty of room at the bottom.